Hi everyone, welcome back to our next video on linear functions and graph. In this video, we're going to learn about equation of a straight line, the gradient, and y-intercept. In that, but however, we're going to start off with the gradient first. What is a gradient? What is a y-intercept? And using these two values, or these two quantities, we're going to form our general equation of a straight line. Okay, so firstly, what is gradient? A gradient is just a measure of a steepness or the incline of a mathematical graph. So over here we have three graphs, blue, green and red. So based on visually looking at the graph, we can see that the blue has the steepest slope, is the most vertical, followed by green and lastly by red. So that is the order of the value of the gradient. Alright, it's basically how steep a slope is. Now, how do we measure the gradient? Alright, the value. We want to sort of quantify it, right? That is when we have our first important formula to learn in this video. Gradient equals to rise over run. Okay, what is rise and what is run? So these are the three steps to find out the rise and run to calculate the gradient. The first thing is to draw or to pick two good points onto this graph, right? So let's say I pick these 2 points. Why are they good? They are good because I'm able to easily find the x and y value of the coordinates. For example, look at this point over here. The x value is just 0 and the y value is -2. Alright? What about this second point over here? If you use a ruler, you are able to easily find that it coincides with the major grids of the x and y values. Alright? So you get a nice value of 4 and a nice value of 4 in our x and y. The next thing is we got to extend out these 2 points to form a right angle triangle. Okay, so normally when we draw our right angle triangle, please do so in pencil. Okay, and our right angle triangle, each of the side represent rise and a run. How to remember? Rise, you think about moving something vertically upwards. Correct? That's what I mean by rising up, standing up. So the vertical part of the right angle triangle is associated with the value of rise. The horizontal part, because we always run horizontally, correct? That is what it meant by the run. So the length of the horizontal part of the right angle triangle. Piecing these two information together, we are able to get a value of run equals to 4 units because our line of this horizontal line starts from an x value of 0, goes to the x value of 4. So it's just 4 units. And our rise, we start off with a y value of -2 and we rise up all the way to the y value of 4. So from -2 to 4, we get a rise of 6 units. Using this, we can substitute back into our formula for gradient and we then are able to get 6 over 4, which gives us 1.5. Okay? Next, we have a negative gradient slope. So what I mean by negative gradient? Notice in the previous graph it is sloping upwards. The y value go from a small number to a bigger number. However, for a negative gradient, we are going from a bigger number to a smaller number. It goes downwards. So first thing, same thing, we pick 2 good points over here. So I pick these 2 good points. And then I'll extend out the line from these 2 points to form a nice right angle triangle. And then I'll label my rise and my run. Do you have to label in exam? You don't have to do so by just labeling for teaching purposes. Okay, so same thing, our run, we start from 0 all the way to 4. So our run is basically 4 units long. Now let's look at our rise. Our rise, we are going from 4 all the way to -4. From 4 to -4, is that an increase or a decrease? Okay, because it is a decrease, our value would then be negative. Alright, so in this case, we have a rise of -8 because we go from 4 to -4. That's a difference of 8, and because it's going downwards or it's going to a smaller number, it is negative. Alright, so then our rise value is -8, our run value is 4. Substituting back into our equation, we get a gradient of -2. Alright, okay. Hope everything is good so far. Next, we will learn about the y-intercept. So y-intercept is basically the y value of the point where the graph intersects, or what we know as cuts colloquially, to the y-axis. Okay, let's look at this example over here. We have our x and our y-axis. The graph cuts the y-axis at this point over here. And what is the y value? Okay, we can just read by looking at a number beside it. The y-intercept is just 2. Let's look at this next example over here. We have our graph. It cuts the y-axis at this point over here. And based on the intervals, the y value will just be -1. So our y-intercept value is just -1. And we look at the last graph over here. We see the graph cuts the y-axis at this point over here, right? And based on the intervals, this will just be -3. So our y-intercept is just -3. Okay, this is clearly much simpler than gradient, but equally as important. Because next, we're going to learn the equation of a straight line. This is the second formula that you need to remember. Y equals to mx plus c. Okay, what is m and what is c? So m represents the gradient of the graph, basically the value as what we calculated just now, as well as c. C represents the y-intercept of the graph. Alright, the y value at which it intersects the y-axis. Okay, using these two information, m and c, if I were to give you some equation of straight lines, are you able to calculate the gradient and the y-intercept just by looking at the equation alone and not having to look at the graph? It is possible, right? This is what we call pattern recognition, finding the patterns of the gradient and y-intercept from the equation of straight line. Alright, so notice m, the gradient, is actually the coefficient of x, basically the number that is multiplied to x. And c, on the other hand, is just a constant number that is either added or subtracted to the equation. Is that clear? Alright, it can be positive, it can be negative. So be wary of that. Let's take a look at the first example over here. We know that from the first example, the value that is multiplied to x is 3. So that the coefficient of x is just 3, which gives you the value of our gradient, right, m. And the y-intercept is basically the number that is added or subtracted at the end. In this case, it's just +6, because you add 6, so you just have a y-intercept of +6. Next, in this second part, we have -3x instead of just 3x. So is our gradient still the value 3? No. Alright, so we'll be careful of the negative sign. Now our coefficient is -3. So our gradient is now -3. Okay. The y-intercept on the other hand is not just 1, but we also have to account for the minus sign in front. So we have -1. So our y-intercept is just -1, as that is our constant term that's added to the equation. Okay. For the last example, it's a bit tricky because I swapped the position of the y-intercept and gradient from the usual positions. Let's take a look at the coefficient of x. So in this equation, the coefficient of x is just -1/2, right? -1/2 multiplied to x. So we just get a gradient of -1/2. And our y-intercept will just be the constant term that is in the right hand side. Just nice, it is just +2 because there's no negative sign in front, so the answer is just 2. I hope this is clear enough for you. Alright, if not, then please come find me for consultation. Okay, moving on, we have this equation, this straight line graph over here, and they ask you to find the equation of the straight line. So what do they mean by equation of straight line? We are trying to get this form of an expression from you, y equals to something something something. Alright, and these are some examples of equation of straight line. So basically the question wants you to reproduce this equation from the graph. Now how do we do it? We will need two pieces of important information. Alright, the gradient and the y-intercept. Okay, so of these two, which is easier to find? Of course, clearly the y-intercept is easier to find. So first we mark out the point at which the graph cuts the y-axis, And that's how we get our y-intercept, which is just 1. Next thing, we get our 2 points, two good points, which we can easily find the x and y values. We form a right angle triangle and we get our rise and run. So in this case, our run is from the x value of 0 to x value of 2. So that's how we get run value of 2. But our rise, on the other hand, is going from a y value of 1 to a y value of -3. So it actually decreased. Hence, we get our rise value of -4. Using our gradient formula, m equals to rise over run, we will then have -4/2, and that gives us -2. Using our gradient and y-intercept, we got m and c. We substitute them back into our equation of straight line, which is y equals to mx plus c. And lastly, our final answer is just y equals to -2x plus 1. Alright, just to summarize again, calculate the gradient, find the y-intercept from the graph, get the two respective value, substitute back into the straight line equation, which is y equals to mx plus c. And lastly, this is how we get our complete credit for the question. Okay, let's try a different question over here. Okay, pause the video and try it by yourself. And after you have tried it, watch the solution and check if your answer is correct. So the very similar steps, we first find the gradient and y-intercept. So y-intercept is just the point at which the graph cuts the y-axis, marked by this point over here. Our y-intercept is just -3. Afterwards, we find another point, alright, another good point, and then we draw our right angle triangle. Okay, after you get a right angle triangle, we then find what is our rise and what is our run. So we get a rise of 4 units from -3 all the way to 1, and we get a run of 3 from an x value of 0 to the x value of 3. Using this, we are then able to calculate our gradient, which is just 4/3. And lastly, we substitute our m and our c into our equation of our straight line over here. And that's how we get our final answer of y equals to 4/3x minus 3. Okay. Now, we have come to the end of our chapter 6, linear functions and graphs. I hope you are able to understand the different learning objectives for this chapter and try them out in practices. Okay, after you have done so, and if you still have any concepts that you're unsure of, feel free to consult me in school and I'm more than happy to help you out. Alright, if not then, that's the end of the chapter. See you in the next video.